Mesa Satellite 60 just came in. The owner says was buzzing, then smoke came out the back. Please check everything. That seems like a good idea. This might be a fun one. First step will be extricate the chassis from the cabinet. That can be fun on these Mesa combos. Got the EV speaker. That explains why I about pulled my back out getting it from the car. Let's get this out and take a look and see what's going on. Well, that came out of the chassis pretty easy. Some Mesas are difficult. Some of them have a screw that comes up from down here and pokes into the top of the chassis. That can be difficult. Some of them, there are RCA connections for reverbs that are hard to, you can't get the chassis out when they're plugged in, and they're hard to unplug. This 6L6 here is really dark. It got way hot. The one on the right has the red. This one's dark gray, and there's a lot of dark burn spots on the plate. This tube red plated. I doubt that this was the tube with the failure at the socket, though. This amp was previously serviced by another company in town that has been doing amps for a long time, and I'm not going to name them because that's a whole shitstorm I don't need. I've never been impressed with the quality of their work, and here's a great example of that. The stock amp had 1 watt carbon composite screen grid, so it's a very bad design by Mesa. And this one's got a silver tolerance band, this one's got a gold, which means that one of these is non-original. So the company that shall not be named installed 1 new screen grid resistor. I don't know whether it was the silver band or the gold band. You should never use a 1 watt resistor for a screen grid. Mesa should not use it. Certainly techs doing service should not use them. Fender used them because that's what was available and cheap in the 60s. There are so many better quality resistors for that purpose in the world. And this one is cracked in 2. See if I can zoom in and show you. See that crack right there? That's where the magic smoke came out. And once that happened, this tube would have had all the current because this tube would have had no current going through it. Once that screen supply goes away, that tube's not pulling any current. This one is going to pull all the current that 2 normally would have, and that's the one that had that black mark. So it needs a new pair of 6L6s and a new set of screen grid resistors. I will use 3 or 5 watt metal oxides or wire wounds, not carbon composite. And let's see what value this is. Probably 470. 525. So that is a 470 ohm resistor. Well, that carbon comp has gone up to 575. So another reason not to use carbon comps as screen grid resistors. They don't always stay where you want them. So this should be a pretty simple repair. I've got some 6L6s for test purposes here. I'm going to change out these resistors, put in a pair of 6L6s, and see how the amp is otherwise. Okay, I've got 3 watt 470 ohm resistors in there. Low mass, really good quality wire wounds. I just wanted to point out the glory of this big finned heat sink on the back of this amp, connected to nothing on the other side. Many Mesas have them. They're purely cosmetic. That's the only place where they attempt to earn the name Mesa Engineering, because it looks like it's some serious piece of kit, but it's blank chassis on the other side. It's marketing BS. Anyway, I've got a pair of Mesa branded Sovtech 6L6s in. I've got the current limiter engaged. I'm going to power it up in standby. I'm watching the current. And before I do anything else, I want to make sure that each grid of the output tube has a negative voltage to make sure that neither tube lost its bias reference, because that could explain all the damage. You know, before I said it could be that this failed, causing that tube to go, and that's very likely. There's also the possibility that one of the tubes lost bias. So before I power anything on for real, I make sure negative 52.62, negative 21.58, 52.5, 22, 21.5, 21.6, 52.6. So let me power this off. Something is really amiss in the bias supply. So let me poke around and I'll report back to you in just a second. All right, no real surprise here. These are the two bias grid leaks for the output tubes. The bias supply is on one side. This goes to one of these tubes. This goes to the other tube. And they meet up with the output coupling caps, probably these two. I haven't sussed that out yet. And where each one is supposed to be a 220K. This one's 220K. This one's like 80K is what it measures. So both these need to be pulled. And I also need to confirm with the amp out of standby with no tubes present that there is no positive voltage on either of these with these disconnected and the tubes out. That would tell me that one of these caps is leaking. Mesa uses 400 volt caps in their amps, and they often become leaky. They should have used 600, 630 volt caps. They just don't, because why should they bother? People buy their stuff no matter how it's built, because it looks cool. Player X uses it, whatever. If Player X had to buy the damn things, Player X wouldn't use the damn things. It's kind of interesting. I've never seen sample written on a cap in one of these before. Maybe it belonged to Junior. Very few of you will get that, because I am old. Anyway, so I've got it powered on in standby. Output tubes have been pulled. Those two 220K resistors are pulled. And one of them had failed. It was like 80K. And the next thing I'm going to do is I'm going to take it out of standby, and I'm going to see what the DC voltage is here and here. It should be 0 or very little. But if I get actual voltage at either one of these, that means that these caps ahead of it are leaking. So actually, let me think about that. It's a little bit tricky because they will have no reference to ground. So I'm not going to get the most accurate reading here. Let me see what I get, and then I'll just kind of scale it based on experience. It's not going to be 0. It's going to start off kind of high and then go down. Let me also see what the unloaded B plus in this amp is. 498. They got 600 volts worth of caps on the first stage, and they got 500 other places. Let's see how safe this is. Out of standby. 489, 490. That's without the output tubes. So it's okay for this test purpose. I started at like 90 volts and it's going down to fluctuating around 200 to 300 millivolts, which is probably just because the cap does not have a path to ground after it. But this one, this one here is staying probably at 241 volts DC. So this one, about 288 millivolts. That's just fluctuation because it has no path to ground. This one, though, 241 volts positive. That would have swamped the negative DC that was present. That would have killed this tube. As you saw, that screen grid resistor went out. It would have, of course, nuked this resistor from the bias supply, because the bias supply is at negative 55 volts. So negative 55 on this side, 241 volts on that side, means that one of these caps is very much leaking. Very, very much leaking. So let's figure out which one it is. Both need to be changed. They both need to be changed for 600 volt caps. They're the same as this one here. Let's see if we can see it. It's a 0.1, 400 volts. Mesa is notorious for using underrated caps in their amps. They offset it with this bullshit heat fin, but you know, where it counts, there's no engineering at all. Sorry, I got to be honest about this. I just don't get this brand. Anyway, let me fix this stupid in it. All right, the culprit was C512. If you have 512 or more capacitors in an amplifier, something's amiss. But C512 is the leaky one. Let's see how it measures. Pardon the clutter. This capacitor is the one that was leaking, and it's supposed to be 0.1 microfarad or 100 nanofarad. And if I can get the leads to stay on long enough. Not getting any measurement across it at all. Not getting any capacitance measurement. This is the one that was not leaking. Let's see what it measures. 98.89 nanofarad. So before the failure and the smoke, the client was reporting buzzing. That's what this would have been. And it would have been building for some time. It's not like the amp's going to be just fine and then all of a sudden buzzes or smokes. These things are build up over time. So I don't have my old ESR meter, which might tell me even more about a capacitor. My old one died and I've not replaced it yet, because basically all I need to know is, does it leak voltage and what's actual capacitance. If I have any questions about the ESR, I'll just change it out. That's a equivalent series resistance. Don't want to go too far down the rabbit hole, but a capacitor should have very little equivalent series resistance. As the resistance builds up, it generates heat, which increases the chances and speeds up failure modes. You can Google equivalent series resistance and capacitors. I don't need to give full lessons on these things. Anyway, 400 volts, SBE 715P, a fine capacitor if the voltage will never come anywhere close to 400 volts DC. This one did, probably from being powered on without standby functioning or from just surges. Anyway, let's get some good caps in there. Okay, we got some SBE 716P 600 volt caps. The 715 and the 716 are very similar caps in most ways. There's not going to be any difference in sound. 600 volts will last a lot longer. We still don't have the output tubes installed. I'm going to power the amp on. Forgot to turn the power on at the wall. I've got a little switch, powers whatever amps I have on the bench, so I can shut things on and off quickly without unplugging or trying to learn where all the things are on different amps. I have one master switch. And before I put those 220K resistors back, or new ones rather, I'll make sure we don't have any DC voltage. Here where we had 250, we got about 200 millivolts here without a resistor, and about 200 millivolts here, so that 250 volts is gone. We no longer have a leaking cap. It's amazing what physics and science will do for you. So let's put some 220Ks in there, see what the bias to each output tube is, then we'll put the tubes in and see what it sounds like. All right, some really good quality half-watt 220Ks in place. If I cared enough, I would have sourced out the same 3/4 watt Vichys that were originally in there, like that one there. It makes no difference in this case. The resistor was not the point of failure, it was the capacitor. These resistors should be absolutely fine. Let's confirm. We should have about -50 something on each one of them. 53.4, negative it is. Yeah, same there, -53.4. Let's confirm at the grid. There's no tube in place though. -53.4. Same there. That's good. Power it off. Make sure that they measure the same in circuit. Then we'll put the power tubes in place. Yeah. Good. All right. So let me pop these tubes in, and we'll see if anything else is wrong with this amp. And a quick note on this whole thing that you've been watching. I don't say this out of ego. I'm far from the only person who does things like this or knows to do things like this. But I want, if you are considering working on amps or you want to know what the process is, we knew that that resistor was bad. We changed them. If I had just powered the amp up at that point with tubes taken out of standby, we would have had a big problem because we had 205 volts where there should be only negative 50. And that resistor was bad, and that cap was bad. You have to go through the entire layer of, each layer of the onion has to be peeled away, get all the rot out, and you have to be very methodical. And to do that, you have to ask yourself and understand what are the conditions a pentode needs to operate, and then what are the conditions a triode needs to operate. And if you can answer both those questions, you can fix almost any tube amp because it's all just triodes and pentodes for the most part. You'll get the occasional oddball. You get the occasional solid state implementation. Transistors and op amps work a lot like tubes if you step back and squint. But it's never just one obvious thing, or it may be, but you have to confirm, because what if, it could have been just this, but I'm glad I checked this, which led me to this. Let's see if there's any other nasty pieces to this puzzle. All right, so all that stuff done, powered up with 123 volts coming out of the wall today on this rainy day. The B plus is at 466.4. One tube is idling at 55%, the other at 41%, but these are not the tubes it's going out with. Let's average that to about 45%. That's really hot for a Mesa, so it's probably pretty much normal. Let's see what this thing sounds like. Really noisy pots, and doesn't seem to be the big field off that transformer. Does not seem to have enough output. It's not a lot to this amp. There's only two tube stages besides the output section. But all right, first thing first, I'm gonna give each pot a squirt of deoxit. Working around, get all that scratchiness out. Put the tone at noon, master at 10. Let's see what the pull shift does for us in a little bit. I believe the tone, the presence as it calls it, at noon. Okay. I have not played one of these before, and I may look up some YouTube videos to see what these things are supposed to sound like, but that sounds really low gain to me. So before I do anything else, I'm gonna pop some different preamp tubes in and see if we have just some weak preamp tubes. All right, I got the preamp dime the way it was before. We had a massive amount of gain and then it all went away. I thought it was just a bad tube, and it may still be a bad tube, but I think one of these connections is iffy. Because it just lost all the gain it had. I wonder. Could be a faulty contact in the effects loop. Let me get a little cable here. That master volume really does affect the amount of gain. Keeps coming and going. I think I got a bad solder joint on the input, so let me take a look at that. Well, it turned out to be some very, very dirty contacts on the input jack, which is a complicated normaling scheme which goes to the effects loop, which also needed to have its contacts cleaned. And it seems to be okay now. If I can remember how it goes. So the amp's still got a little bit more hum than I personally would like. I think it's probably those old filter caps. I'm going to share this video with the owner because he has two of these amps. He likes to use them in stereo. And I need to get the new 6L6s in before I try to convince him to do new filter caps because these are not perfectly matched. But I do suspect that these caps from 1996 need to be changed out. And there's only 4 main filter caps in the amp, and I do the 2 in the bias supply at the same time. So it's not a lot of caps to change out. The amp is sounding a hell of a lot better now that it's not trying to catch on fire or kill itself, and the input's not cutting in and out. So I need to put the original preamp tubes, which were, well, not original, but the tubes that came in with a pair of JJs back, because I put in some tongue saws just to troubleshoot. And remember at the beginning when I thought the amp was just way too quiet for a 50-watt amp? I was right. Anyway, very good progress. I'm going to put this up for you guys to see. I'm going to send a link to the owner, and then I'll talk to him probably tomorrow and see where we go from here. But I bet if I got rid of these old filter caps, changed out that 2 or 3 watt carbon comp for something better for reliability, change out those 2 in the bias supply, the last of the little buzzes would go away. The rest of it was just cleaning and tightening. I'll put some fader lube in all these pots now that I've got them cleaned. And there's at least one tantalum cathode bypass cap there I would like to replace with electrolytic or film, depending on its value. There's 2 actually. There's one down there and the one down there. Tantalums like to fail in Mesas, and I like to get rid of them. And I just realized my guitar strap was rubbing up against the microphone for the last couple minutes. If it sounds really bad, I apologize.